Okay, so two things in 5.1, right? Okay.
Yeah, so two areas that I saw people both struggling on, myself included, was 2A and 2F on 5.1.
Mhm.
I think for a lot of us, it was just not knowing where to start.
All right, so 2A and 2F. Okay. So by the way, have you found Discord to be useful?
Yeah, it's incredibly useful.
Right, because as faculty, we kind of wonder what are good forums for students to interact on, because it seems like Canvas has been off and on. Actually, I had a colleague who used a forum on My Open Math, which seemed to work very well. So I don't know if you or your colleagues have experience with good student forums, maybe that maybe the instructor could also interact with.
Yeah, Discord's a really good one since a lot of students already tend to have it. And I think Canvas is really good for your grades, but that's about it.
Ah, okay, that's the impression I got. That
That's my experience so far.
right, that people were thinking about Canvas and grades, but it wasn't so good as a discussion forum. But Discord, and that's something that is that something that instructors sometimes dip into?
I've never had a teacher that's done anything with Discord, but I've had countless classes where students, like 20, 30 students, all make a Discord to
Do you
talk about
think
the class.
do you think that an instructor presence would be welcome?
Yeah, I don't see why it wouldn't be. The, it depends on the class too, because if the class is, there have been times where it wouldn't really change anything if a teacher was there or not, because everything's entirely professional. But then there's also times where people are goofing off. But
Sure.
again, I don't think like people making jokes is too different than, the videos you share with us, and we have the chat on the side during Zoom.
Right, and I'm hard to offend personally, but I guess it
Yeah,
might depend
so
on the instructor. Right. But that's interesting because because I think maybe if I did more with Discord, if that's what students are going to, well, then I should learn more about Discord. Now, I do intend to learn more about Canvas also, but um, maybe Discord, because I had a student who actually took videos of me when we were on campus, and he posted them on his Discord site. Actually,
yeah,
that was about a year or two ago. In fact, in case if you see my desktop, see this? Can delete Math 141 videos. That's his videos.
nice.
It's taking up like 41 gigs on my hard drive, but
Damn.
that's why it says can delete, right? In case I run out of space, but I have a 4 terabyte hard drive now.
Yeah.
Yeah, but thank you. Yeah. Okay. So that's a discussion we could have at some time. But I'll
Yes.
look into Discord. Yeah. But anyway, let's get back to this now. Well, any comments about that before we go to this?
Yeah, real quick.
Yeah.
If you want to join the server for that we have for this class currently,
Mhm.
just let me know and I'll send you the link.
Oh, cool. Yeah, let me make a note of that. And I might tell my colleagues to ask their students if they might be up for that, like them doing Discord, just to let them know that it's a thing.
Yeah.
Yeah, because the thing is, we've talked a lot about Canvas, but my colleagues have not talked about Discord. But I know the students talk about it.
Yeah. The only thing you might find weird about it is, especially with our server, at first there were a few instances where I helped out other students consistently,
Hmm?
and they accused me of being you.
Oh, okay.
They were like, "Wait, are you Ken?" I'm like, "No.
Another one of my pranks. No.
Yeah.
Okay. Okay, that's fine. Anyway, let's see. So let's go ahead and start with this then.
Okay.
All right. Okay, so 2A. Okay, I'll grab my little whiteboards here. Should have had those up. Okay. Okay. All right. All right. Is your printer running? Because I just got a new printer over the weekend.
I share a printer, so I have to like go grab the whole thing and move it into my room if I have to print anything.
Right. Okay. All right. So let's start then. Okay. So A, right? 2A. Okay. So I'll first I'll note this is five. We're on 5.1. 5.1, right? 5.1, 2A. All right. Let me. Oh, and yeah. By the way, tablet. Tablet.
Oh yeah. I pitched in a little on that, so I'm glad you're enjoying
Thank
it.
you so much. Yes, thank you to the whole group for that. Yeah, it actually is smoother, right?
Yeah,
So
they're
yeah,
really nice.
right. All right. Okay, so all right. So on 2A, okay, so let's see. Let's change the color to blue. All right. Okay, so on this one here, okay, so so the given, I'll go and write down the given. All right, so okay, so one if you're doing a verification problem, you can just put LHS or RHS to say where you're starting from. It is normally good to write down the given. Although I wouldn't mark off for it. So 1 minus cosine of opposite x. All right. Okay, so first of all, it's kind of irritating to have these little opposite or negative signs in there.
Yeah.
Okay, so we can use the fact that secant and cosine are what kinds of functions? Do you remember?
Even.
Very good. They're even,
Yes.
right? And that's how we take care of those irritating -1 factors on these arguments. Okay, which means what can we do with these signs? We can, well, we can get rid of them.
Yeah.
Okay. Okay. So then, go back to blue here. All right. So then we have 1 minus. Okay. So when you kill the negative, you have a secant of x all over 1 minus cosine of x. All right. Okay. So then we take care of that whole the whole negative sign deal in there at least. All right. Okay. So that was the even odd properties right there. And then a couple of things. First of all, it's kind of natural for us to want to break apart these one of these four more complicated trig functions in terms of sine and cosine. But also these are more close. These are also related directly to each other. So
Yeah.
it's both going down to sine and cosine, and also the fact that these two in particular have a very direct relationship with each other, right? Because they are, what's the R word? They are
Reciprocals.
reciprocals, right? Okay, now it's a simplification problem. If it were a verification problem, then the right-hand side or the other side would tell me which way to go, from here to
target.
here or backwards, right. So for example, if I had a right-hand side, a target that had secant of x, then I might actually want to rewrite this in terms of secant of x. But since this is a simplification problem, I might just go with my inclination and just rewrite secant of x in terms of cosine of x if there's not a clear direction to go in, right? Okay, so we have 1 minus, okay, by the reciprocals, identities, secant of x is 1 over
Cosine.
cosine of x, right? All over the 1 minus cosine of x, okay? And like I said before, if this were a verification problem where we had like a secant thing on the right-hand side, then we'd actually want to rewrite cosine of x as 1 over secant of x probably, which is unusual. But again, if you had a secant thing on the other side, you want to aim for the target. But for these simplification problems, you can go with your instincts and just kind of go with this whole sine cosine thing. All right. Now, I know it looks really tempting to try to strike something out. Do not strike out the ones, for example, right? You can't do that at this point. You don't want to do top-down striking if you have two terms on the top or the bottom, right? So we're not ready to strike just yet. Okay, so now here's where I'll give you a choice. There are two general approaches that one can take. One approach that one could take is that you could take the numerator and turn that into a single fraction. Another thing you can do is to multiply by the LCD over itself. So I'll leave it to you. We could even do it both ways. Which is your preferred method, to make the top a single fraction or to do a multiplication by 1 trick?
Multiplication by 1 is what I'm more familiar with.
Right.
And
Yeah,
I think I've tried it before.
Yeah, I personally tend to prefer that also because I like striking things. Maybe it's just because I get an aggressive move. I like to strike things out, right? Because I can't strike it out now, right? But also, I think people have trouble with compound fractions, right? So there is some danger with that. But we can do it both ways. All right, anyway, well, the overall LCD is just cosine of x, right? So we just multiply by cosine of x over itself. All right. And then for good measure, I'll put this in brackets. Now that's not technically necessary because the fraction bar automatically groups the top as well as the bottom. But the thing is, I think the grouping symbols help emphasize that, yes, this thing does distribute to both terms, okay? Because a lot of students are tempted to go strike, strike, and they can't do that, right? You have to distribute first before you start striking in that sense. All right, any questions thus far?
Yeah, we are getting closer to where I got stuck.
Mm-hmm. Okay, so let's go one more step here, all right?
Yeah.
So then next would be the distributive property, right? Where cosine of x does hit the 1, right? 1 times cosine of x is cosine of x.
Yes.
Right? Minus, and would you agree that if we hit this fraction with cosine of x, we get 1 remaining? Would you agree with that? Yeah, okay. All over, now, I guess I should have put the grouping symbols around the bottom as well. As I said before, the fraction bar groups the top and the bottom. But now, I know that a lot of students are tempted to distribute on the bottom because they want to show their stuff, right?
Yeah.
They want to show their knowledge. But the thing is, actually, we prefer to keep it factored, okay? Because we actually prefer factors when we do striking. Yes, go ahead.
So this is where I kind of had a question real quick.
Right.
I believe it is x minus 1 over 1 minus x and other similar functions that we kind of get another version here. Evens out to like
You're right. You're exactly right. Yeah. So let me write this down. And again, don't distribute because it turns out that we do like the. I lost my O here because we do like the factored forms. Oops. Right. Okay. So I'll let me do on the bottom the quantity 1 minus. Oops. One minus cosine of x. All right. All times cosine of x, right? And you're right, is that whole jazz of if you have like y minus 1 over 1 minus y, well, tell me, what does this divide out to? What's the quotient?
-1.
Correct. By that kind of switch rule for subtraction, right? Okay, so it's the same idea here, right? We have, I'll go ahead and group this again. You don't have to. The fraction bar automatically does that. But we have cosine of x minus 1 over here as a factor of the entire top. It is the top. And then 1 minus cosine of x as a factor of the entire bottom, the entire denominator. Mm-hmm. Boom, we got that. Okay, so I'll put -1. Okay, it's a good habit to put parentheses, though. Here it's not necessary. Over here, 1. That's good to do as a habit, right? You agree with that, right? Do you agree with that?
Sorry, let me. Yeah.
Right. Okay. So then we get equals. So you agree we have a -1 on top, and that negative sign pops out, right?
Yes.
Okay, so the opposite of 1 over cosine of x. Do you agree up to there? Are there any questions or any pieces that you have?
No, that was the part that I was confused on. Was I wasn't sure because I don't know if you've mentioned it. Mm-hmm. I don't know if some math teacher in the past has mentioned it, that like 1 minus y over y, or you know what I'm talking about. Yeah.
This thing here, right? Hmm? I mentioned it.
So I was hesitant to use that when working on this problem.
Yes. But it's one of those things that calculus teachers just expect their incoming students to know. But I totally believe that smart, competent incoming calculus students are going, wait, what's the relationship when you switch around that? Because I know in your basic algebra classes, you may not have been taught that. I emphasize that because I've taught calculus. And it's one of those sneaky things that they pull on you from time to time, right? Yeah. And the reason is that because the top and the bottom are opposites. Basically, if you believe that 5 divided by -5, for example, is -1, by similar reasoning, you should agree with this, that anything over its opposite, as long as you're not dealing with zeros here, anything divided by its opposite will give -1 by this similar reasoning. Right. Okay.
So for the sake of time, since a lot of what the students were asking for was 5.2, do you mind if we move on to that?
Okay, sure. By the way, let me finish this.
Yeah, sorry.
1 over cosine of x is secant of x.
Yes. Or negative secant of x.
Right. Well, yeah, the opposite of secant of x. Okay, and that's it. All right, good. And by the way, no rush. I'm going to go a bit past 7. That's fine. I don't
Okay.
think I have any other students signed up right now. So okay. So I'll go ahead and save this.
I mean, I'm sure I have more questions than you have time, so just feel free to let me know whenever you have to go.
I think I'm good. I think we can go on as long as you need me. That's fine. All right.
Okay, cool.
Okay. So let's see.
So the questions, it seems like
Oh, by the way, there's also F. Or did you want to? Do you want to do another section?
let's do F just so that we have 5.1 wrapped up, because
Right,
that was
okay.
I saw 2 other students seem to have trouble with A and F, and
Right.
I did as well.
Okay. So again, I'll go ahead and this is 5.1.
And I think I saw you talk to someone about 2B.
Yes, right.
Yeah.
I did that after class, and that is
Yeah.
on recording. Right. Okay.
Some people asked me about that too.
Sure.
But
So
I
you
can
tell
explain that one. So
right. It's in the class lecture after class.
Okay.
It was recorded. Yeah. Okay.
Cool.
Let's see. Okay, over here. So I'll go ahead and rewrite this.
Yeah, for this one I kept getting 1. And I know that's not right.
I know that there are ones that creep up from time to time, right? But and I know there's a lot to keep track of because it's a massive FOIL problem.
Yeah.
All right.
Oh, that's a good way to write alpha.
A fish.
Yeah, no, I kept writing it like a normal A, and I was like, this is going to get confusing because how do you differentiate it? But yeah, no, kind of like a fish is a great way to write it.
Exactly. Right. Okay, so first off, again, I'm playing that even odd stunt on you. This time, well, even odd. Tell me about cotangent and cosine. What are your thoughts?
Okay, cotangent, you're going to have to pull the negative symbol out, but
Correct, because
cosine,
it's
you
an
can
odd
just get
function.
rid of
How about cosine?
it. You can just get rid of it. Just
Right,
keep it positive.
cosine is even, correct. So we can
Okay, so real quick, just a side question. That first step that we just did is kind of where I start off, because I tend not to write the original question. I believe we talked about that before.
That's fine, and you don't have to write
yeah.
the given. In fact, if you put star equals, so yeah, if you put like
star equals is the given.
Yeah. Just, I mean, I think it's a good habit, at least to note to yourself that there's some instructors who might want you to write the original.
Yeah.
Now, by the time you get to calculus, they'll have their own methods, but I mean, these are really pieces of calculus problems, really. And certainly, if you're ever asked to verify, like if you ever took a placement exam or something, then you should at least indicate which side you're starting on. But these are simplification problems, right? Anyway, you're correct that because of the odd property, this guy gets pulled out. All right, good. All right, very good. Okay, so let's go ahead and do that. Oops. Okay, so let's pull up the opposite signs. We get opposite of, cotangent of, cotangent of alpha. All right. Oops. Bracket 1. Okay, and then plus cosine of alpha. This negative dies over here. All right. And then it's a matter of foiling like crazy, basically. So, which is really distributing. When you foil, you're basically distributing. Okay. Cosecant of alpha times 1 is cosecant.
Okay. Yeah. So this is immediately where I went wrong.
All right. But you said a couple of students were asking about this, right? So let's.
Yeah.
Okay, but anytime you want me to eject, let me know. And we have time to work on this. I mean, we have the homework sessions. Okay, so plus outer product. All right. Cosecant of alpha times cosine of alpha. I know it gets all very confusing. And then inner product, I. Opposite of cotangent of alpha times 1. That's just opposite of cotangent of alpha.
Would you mind if I simplified cosecant and times cosine in the same step? Like if I just combined that? Because that is 1 over sine, correct?
That's correct. I'm okay with that. Generally speaking, I think it's better to
show it all.
Right. Yeah. So
Okay.
key algebra steps and applying basic, the fundamental trig identities. What you just said should be fine. Any calculus instructor would accept that you know what you're doing. But be careful. I just want to say, be careful about skipping steps.
Yeah.
Certainly, if you're operating on two different pieces of the same thing, but if you're doing like an algebra thing and an identity at the same time, not that you couldn't do that. And let's say you're doing a timed exam. If you're running out of time, do it.
Yeah.
But if you have time, right? Like you're not rushing on your homework, go ahead and take things step by step. Although again, if you're operating on different pieces totally separately, that's fine, right? Okay, that's just my advice. Okay, minus cotangent of alpha, cosine of alpha. All right, and then the next step will break things up. All right, it's a simplification problem. I don't have a target, so going to sine and cosine, would that be helpful? Perhaps, right? Oh, now. Well, yeah, okay. Okay, yeah, that's okay. And then we can go back if necessary. Well, whoops, over sine. Because one thing about sine and cosine is that if there are any cancellations or anything, it's good to see them, right? We may eventually have to go back to cosecant, but all right. So we have cosecant of alpha is 1 over sine of alpha, all right? We'll see if we really need to do that. Plus, as you said, cosecant of alpha is?
Oh, cotangent. Sorry, I'm writing stuff down.
Oh, that's fine. All right. Okay. So, oh, no. See, I'm looking at the second term over here. Right?
Yes.
Right. I'm not doing the bottom one, right? So cosecant of alpha is 1 over sine of alpha. I know it's so long that it went past my that's a bad sign. But it's not too bad. I mean, yeah, so 1 over, it's not too bad. It's just kind of long. 1 over sine of alpha times cosine of alpha. Oh no, these can get really heinous. This is not that bad. Okay, minus. Let's break it up for now. Okay. Oh well, look at this. What is cotangent of alpha? Use the quotient identity.
Cosine over sine.
Yeah, and lo and behold,
it should cancel out with the thing next to it.
Yeah, and even though it's not verbatim, I believe that you know that they're equivalent. That you don't have to prove to me. But let's see what happens over here. Minus. Let's break this up. Cotangent of alpha. Again, that's cosine of alpha over sine of alpha. And we get something nice here. Because we have here, well, let's write this cosine of alpha over 1. How about that? Let's do that. All right. So as you just noticed, and I totally believe you, all right, this ends up being cosine of alpha over sine of alpha, opposite of cosine of alpha over sine of alpha. Goodbye. I believe that. Okay. So, you don't have to manually stick that guy up there. I believe you. All right. Any questions so far? Any questions?
No, none.
All right. Let's go on. All right. Okay. Equals. Okay. Yeah. So maybe breaking up's okay here because 1 over sine of alpha, because we have sine of alpha in both denominators. All right. Minus. Okay. Well, cosine of alpha times itself. Cosine squared of alpha, right? Over sine of alpha times 1, that's sine of alpha. Okay, so what we did here wasn't a waste of time because I think I can use that common denominator. Any questions thus far?
No, so what you're left with is 1 minus cosine squared alpha over sine alpha.
You got it. You subtract the numerators. Okay, of course, don't subtract the denominators. Keep it, right? Sine of alpha. And
wait.
Go ahead.
Wouldn't that give you 1 as your answer?
Not quite. Oh, wait. Not quite. What is 1 minus cosine squared of alpha?
Oh, wait. No, that's right. Never mind. I'm mistaken.
Okay. I know it's tempting. Yeah.
Yeah. Okay, that's where I was making the mistake.
Right. Oh, yeah. In trig, there's lots of wishful thinking, and you have to train your brain to not fall into wishful thinking. I do that too sometimes. Okay.
Yeah, no, this is a step I just didn't write out, and then I was like, oh, it's just sine over sine. Cancel them out. What? No.
Oh, careful. Again, what's 1 minus cosine squared of alpha? That is?
Sine squared alpha.
Right. Sine squared of alpha is not quite 1, but it's not too bad. Sine squared of alpha over plain old sine of alpha. What is that?
Sine.
Sine of alpha.
Sine of alpha, yeah.
Right. Right, don't forget the argument. Lots of students forget to do that. Okay, I'll box that in. Doesn't get any better than that. And this is the answer, right?
Yes, yes. No, I kept getting 1 because of the reason I stated.
Because you thought that was sine of alpha, right? Right.
Yes.
Okay. But remember, we associate the Pythagoreans with squares. Again, squares can be your friend in trig because of the Pythagoreans, exactly because of that. In fact, if this were just one, if there were no square, if there were just 1 minus cosine of alpha, you'd have to tear it apart, and then we'd probably have to reverse some of our steps up there, tear it apart, and use the reciprocal quotient. Which means we probably wasted our time with some of the stuff up here. But you never know. You never know.
Yeah.
Remember, I don't require the absolute best solution from the book as long as it's reasonable, right?
Yeah.
Okay, that is the answer, right? Is that right? Okay.
Yes, I believe so.
Okay, I have the answers here. Yeah.
I was about to check, but yeah, go ahead.
Yeah. Was this 5-1? Right. Right. F was sine of alpha, and we did A opposite secant of x. Okay. Right. That was there. All right.
Okay.
Okay. Next up, so yeah, it's 6:57, but I'm fine with going on. The only drop dead time is 7:45. That's when I have to start preparing for my trick stats class. All right. Let's see. What other?
So the thing is with 5.2,
Okay.
it seemed like people were having trouble with it just outright.
Yeah, right.
So B through D, I could start B and C, but I just wasn't certain of how to continue. And I haven't yet tried F and G.
Right.
At some point after I realized I wasn't sure how to do most of it, I was just like, I'm going to keep moving on to the next section and come back to this.
Yeah, right. That could work too. And the thing is, I'm kind of efficient with my homework sets. It's not like a textbook where they have like the odd one and the even one on the same line or the same type. I don't play that game. So it's like these have different flavors. Like for example, G is going to take you back to chapter 0, right? These fractional exponents up there. And in fact, I'd recommend a substitution for that. B, I think I did. Apparently, I did B sometime. I don't think in office hours. I think this is somewhere in a recording. Okay, so you can pick one.
Let's just start with B then, if you don't mind.
Well, now, as I said, B might be in a class video. We could do it. We could do it, but I think that's in a class video. We could do it, but I would suggest another one just to save time.
That's another thing, real quick, if you don't mind. With 5.2, I went back and looked for your videos, and there seemed to, I don't know, maybe it's just me and looking through your playlist and I missed something.
Right.
But there seemed to be a gap where it was you would start 5.1, and then the next video I found in the 5 section was the end of 5.3.
I wonder if there was a misordering. In fact, I can check that right now, actually.
Yeah, if you don't mind, because I did exactly this. I looked through it. I was like, I don't remember this. I need to rewatch it.
Right. Or I could have, maybe I reviewed the identities. Let me, okay. Do you remember where it was?
It was day 22, I want to say. Because I think that's your ordering system, right?
Right. I going by day number now. Right. Okay. So that was last week, right? Thursday of last week. Right.
I believe so.
Right. Oh yeah, day 20, because day 21 I went over questions, right?
Yes.
So well, in part 1, so yeah, we were starting off with
5.3. So then I went to the one before that.
Right, we're continuing with trig equations, right? And then let me go on.
Hey everyone, we just solved the equation.
And then the follow-up to that.
X minus 3.
Right, I followed up on that. And then the factoring techniques.
Yeah. So this is the 5.3, but what I was having trouble finding was 5.2 and the end part of 5.1.
Oh, yeah, because remember, I normally, I follow the scheme from on campus where I normally do start a unit before the homework is due. So that would be week 10.
Yes, I believe so. And I went into that, I think.
Right. Okay, so let me go back then.
Sorry for not communicating that better.
That's okay. No, we have time. So that was the previous week, like 19. Oh, that was up here. Yeah. This order's messed up for me, but that's okay. Let's see. So yeah. All right. Yeah. By the way, I just noticed that the playlists are all jumbled up. You can sort them by latest video, and I'm going to start doing that to at least order the latest ones. But going back, that's a little tricky. Yeah, yeah. You have to kind of search for the date. All right, and I'm going by Monday. I'm going by the Monday date. Okay, so yeah, this day 20. Yeah, yeah, yeah. So day 20 was when we were. Here's 19.
Yeah, so most of that should be chapter 4,
So
and
20.
Hi, everyone. We're continuing with section 5.1.
Yeah, we continued with 5.1 on simplifying. Yeah, this is simplifying, right? So yeah. So I'll go to my syllabus also. Oh yeah.
would you mind going to the last video in that playlist?
Right.
Sorry,
The
I
last
just
one
want to
here. Oh yeah, the last one here. Aside from the class video, 11.
Okay, never mind.
Hi, everyone.
Then you have it all there. I don't know why, but I looked in that playlist and I couldn't find anything on 5.2. But if you have between 5.1 and 5.3, then that must mean.
Right. Yeah.
All right.
Yeah, I think
All right, I'll go look at it later.
yeah. It's confusing. Let me. I have to do this anyway. Let me grab my. So I got to get this out anyway. I always mark it up. Okay, syllabus.
At the end, you have the calendar, right?
Yeah, exactly. And I'm following the calendar.
Yeah,
I'm
that's
really
actually
following,
how I went back and found what I needed.
yeah, I'm really following my on-campus scheme. And instead of exams, we have homework sessions, and that's why I think students are learning more this way. Because instead of test time, we're just going over things more. All right. Right. So. Okay. So we're talking about this area here. So I just showed you day 20. And so start 5.3, that's what I was doing. I was starting trig equations in that last one. And then we had that big old homework session. That was just a class video on Tuesday. And then last Thursday, I continued the trig equations and then introduced the advanced identities.
Okay.
Right. So it's all there. But I know it's kind of a mess. And, I was Googling how do you reorder playlists on YouTube? And it's sad. I see obsolete videos, and it's sad that on YouTube, a basic function like reordering playlists, they don't have a clear way of doing that. It's sad.
No, I've also had a similar experience recently where I was trying to figure out how to solve a problem, and the latest resolution was from 2013, and that hurt. the most recent solution for the problem. Oh,
Right.
it sucks.
Although with math, it's not so much of a matter of
No.
but still organize the dates. And remember, if you ever get confused, see, it's good to have my calendar because remember that I organize the videos by the Monday date, right? So week of like November 2nd, November 9th. So yeah, if you go by the calendar. Now, I guess well, I don't know because I went to someone's Canvas site and in principle I could do this on Canvas. But it depends if you want to log in and all that. But Discord, huh? So what is Discord used for? Is Discord used primarily for classes or?
So Discord's typically, from my experience, it's kind of just a everything and anything.
Mhm.
It's a good utility overall because you can create different rooms for chatting, just like text-based conversation.
Uh-huh.
You can also have voice-based conversation rooms, and they added a feature not too long ago where you can show your screen. And I've used that on a few occasions, just pulling up a blank piece of, like a blank note document like you do to draw out problems for people to explain things. So it's just a good utility overall. And you can find servers either, that your friends make or based on subjects that you're interested in and so on. It's just a general thing. I wouldn't really say it's for any one thing, but what people typically use it for is gaming, I guess.
I've
What
heard.
my experience has been.
Right, and that's why you want to share a screen, right? It's like showing what you're doing. I heard that. I think the student who did the videos for me, right, who did Discord, told me that he used it primarily for gaming. But it's funny that how with my colleagues in the math department, I don't remember it being mentioned, or it's rarely been mentioned. It sounds like it's a great resource if students are using it. I mean, come on, how many? Well, you said that. Is this originating from the gamers in the class, like people who?
The gamer, I don't know, dude. As far as I can tell, there's only one person that's been actively playing games in our class, because sometimes if you have Discord set up for it, it'll show you if you're doing things on linked social media. Like if you link your Steam account or something, it'll show if you're playing games or not.
Oh, uh-huh.
And sometimes like when we're outside of class and people are working on homework, it'll say that he's playing Overwatch or something. But aside from that, I don't think anyone else has been playing games really. I think a lot of people tend to use it because for a lot of people, it is just for gaming and basic communication. But then I've noticed a lot for classes, especially college classes. It tends to get used as just a way to communicate with other students.
Huh, that's interesting. So maybe people just got kind of used to it. Like someone said, hey, why don't we try Discord? And students try it out and they go, hey, I kind of like this. So
Yeah.
maybe it's kind of word of mouth, huh?
Yeah, that's what my impression has been.
Yeah. Do you sense it could be a useful tool for teachers? Is this something I should mention at a department meeting sometime? Ask your students, hey, would you mind if I set up, or if one of you wants to set up a Discord account?
I would suggest this. I'd say that if your students are already planning on doing it and you don't mind,
Mhm.
I'd suggest joining. I think it could only be beneficial, but going out of your way to make a server entirely depends on whether students already have Discord accounts or not, you know?
Right.
It's kind of like Zoom. We are required to have it because for school purposes, we have to attend Zoom classes.
Right.
But Discord's kind of like, that's the thing, is we don't have the whole class in our Discord server. We have like maybe 12, 15 people.
Right.
But that's another thing too, is I think a lot of more people would join if they found it as an easy way to contact you, because it is a lot more convenient than email.
Right. And it's free, right?
Yeah, it is.
Yeah. Well, as long as it's free, I mean, why is it any different from Zoom, right? I mean, as long as it's something that...
I have heard it as suggested before as an alternative to Zoom.
Huh. Because now you can show the screen and all that, huh?
Well, that's another thing. Zoom's better for that, in my opinion.
Right. But
it's a more of an all-in-one place kind of thing.
Yeah, because I'm actually evaluating a colleague, so I went in on their Canvas site, and basically this instructor wasn't able to get much on the Canvas site unless it was a graded discussion thing that students had to do. But the instructor was also using My Open Math, which is like a homework system, and the forums were very active, so the students were willing to do that. But Discord's something that's more natural for about a third of the class, right? So that's something to think about.
That's another thing too, is you get a lot of students that often talk in Discord, like the same maybe 5 people that are often talking. I also noticed they're often the ones attending your class.
Right.
So I feel like it's typically or attending not your class, but your Zoom sessions.
Yeah, that's class. Yeah.
Yeah. So I don't want to say it's the people that are more actively like attending your class, but I'm noticing that it is a lot of the same people that are in both.
Well, it's the engaged students, right?
Yes.
Yeah. That's a great idea. Yeah, I think I'll look into that. Right.
Yeah, definitely.
Okay, so well, before we go on, any more comments on that before we go on? And by the way, I invite any feedback of that kind, because I want more, because that's one thing my class is lacking: student to student, right?
Yeah. That it's been really convenient. The only inconvenient part I'd say is it takes so much, because like I remember in chapter 0, I was like helping people work through problems, and they're problems that if you show your work take up half a page. And so typing all that out really sucks.
Oh, uh-huh.
But I mean, aside from that, it's just generally really convenient. All right, so we were gonna do C.
Do you want to do C? Okay. Yeah, because
either or.
Yeah, either or. Yeah. And I shouldn't. The thing is, I haven't decided yet which ones I'm going to grade. Right. So what if I do grade B? That's possible. Okay. So let me. It's your choice.
So that's the thing with B, is I think I see.
Oh, you know what? While I mention it, that means that I must have it in my files. Let me just grab it from my files then.
Yeah, let me check the answer real quick, because I might have it now that I look at it again, because I started it, and let's see, 5.
Yeah, so you don't have to skip it.
5.2 says solutions may vary.
Yeah, because yeah. Yeah, I don't have to skip it. I can just kind of, I have it in my files. Then I can just,
B is, yeah, no, I see what I
here we
need
go.
to do.
Here we go.
I-
521B.
Yeah.
Yeah, exactly. Oh yeah, I just went over this. I think it's in the
It's
most
the
recent
same thing that we just did.
class
The
video. Yeah.
y minus 1.
Right,
over-
exactly. The x minus 1
Yeah.
and 1 minus x, right. So very quickly, let me skim over this because who knows, I might grade it. You don't know. In fact, it makes sense that I would grade a problem that's in a video, right? That would tend to make sense. And I told the class, hey, if I know something's on a video on my YouTube site, well, hey, if anything, I'm more inclined to grade something like that. Solutions right there. All right, so let's go over this and let me know if you have any questions. So I didn't rewrite it, but I told the student, hey, I just realized it then, actually, maybe a substitution would help, right? Because you have very similar pieces here.
Yeah.
Now, back in the previous one, you had like cotangent, cosecant, sine, maybe not that, but here, sine and cosine, right? Or powers thereof. So I let x be sine of u, I let y be cosine of u, and basically it has this structure. Look at this, xy minus y, very simple, all over x minus x squared. So this ugly looking thing, after substitution, that may be half the battle, right? That thing looks
Yeah.
very crackable, all right? Then you factor out the GCF on the top and the bottom. On the top, it's y. On the bottom, it's x. And as you see, here are the other factors. And they're opposites, right? X minus 1 is the opposite of 1 minus x. Boom, boom. You end up with -1. Although remember, when you cross something out, it's good to put something in its place. It's a good habit to leave a 1 there. We don't like blanks. Okay, any questions thus far? Any questions?
No.
And then okay, after that, I basically realized I get the opposite of y over x. The opposite of y is cosine of u over x is sine of u. By the quotient identities, that's cotangent of u. Don't forget you have the -1 factor in front, so it's the opposite of cotangent of u. And we've hit our target.
Yes. Yeah, that checks out for me. I mean, once I actually looked at it again, because I had started it a little, like I said, I looked at it, I was like, wait, I just did this. I know how to do this now. Because that was, again, another thing where I was like, I'm not sure if I'm allowed to do that. If that's allowed to just equal -1, or if I have to explain that.
Oh yeah, but I'm really glad I'm going over this with you. I intentionally mentioned these issues in class. I want to put these in the homework because again, in your calculus class, your calculus teacher will expect you to know this. Oh, it's just basic algebra. And yet smart, competent, conscientious students, it's like we weren't really aware of that relationship, right? Yeah. I mean, to be honest,
that's the thing is I was, but I wasn't sure if like it was if I was expected to know it enough to the point where I could just be like, yeah, this equals -1.
Yes. So I went over that in chapter 0, but chapter 0 was a train wreck where
Yes.
this was one of 1,000 bits of information.
Yeah.
And again, this wasn't a review because, looking back, I would doubt that in my own high school algebra class that we did stuff like that. But
I don't think it was mentioned.
Yeah, but the thing is, in calculus, right, you routinely hit proofs and problems where you run into this kind of thing, right? So
Okay.
pre-calc, yeah, good to know. X minus 1 is the opposite of 1 minus x. Unless there's 0, the quotient is -1.
Okay.
Right.
So
good. It's that sticking point that you now know well.
yes.
Good. That's the point of the class, right?
Um,
Right. Feel free. So that's well. I'm showing this on the screen. So video folks, it's right here. It's okay to copy when I'm showing it to you.
Should we continue on to C then?
Sure. Yeah.
All right. So the first thing I did was the tangent. You can pull out the negative and make it a positive.
Correct. Okay. So let's get a new whiteboard for this.
Yes.
Okay.
And then would you advise turning that 1 over tangent into a cotangent?
Well, let me hold on a second. Let me grab.
Yeah, take your time. Sorry.
Okay, and this is 5.2. Let's see. All right. Now, first of all, we tend to go from the larger, more complicated piece to the smaller piece. It's kind of hard to blow up the right-hand side. So, as usual, we're going to go from the left side to the right side. Although not always. Like on F, for example, I just had a student email me about this. A lot of students go from right to left on this one. But if you want to go left to right, you can use the trig conjugate trick. So either left to right or right to left would be appropriate for F. Now for C, almost all students would go left to right. Okay. Now let's. I'll go ahead and copy it. Do it in purple. Okay, so I'll copy the, or you could write LHS. We can just write LHS, that's fine. Okay. You should indicate which side you're starting with, all right? And you're right, the first step is to use the fact that tangent is odd, all right? So 1 over tangent of alpha, that flips to a plus tangent of alpha. Now, I don't require this on the homework, but, you know, just as a student note, it's nice to say something like, oh, I can type it for your benefit, for your notes. Tangent is odd. I recommend that students keep these folders for life, as I would.
Yeah.
All right, tangent is odd. You're gonna need this stuff through your calculus career, all right? Okay, and then you're wondering about the next. Okay, so you're asking 1 over tangent, do you want to go to cotangent? Actually, no, because see, if we had started with cotangent, we might want to do this instead, right? Internal consistency. I think internal consistency might help us here, right? So I think I want to leave that as 1 over tangent of alpha, okay? In fact, and you can do this right now, over 1. That doesn't need its own step. Over 1, that's totally fine. And then we can think of these as a sum of fractions, right? Well, let's get a common denominator. In fact, since you're not blending things here, it's fine to do it right here, right? Let's multiply by tangent of alpha over tangent of alpha, right? Let's build up the fraction so we get a common denominator. Any questions about my strategy here? And again, it's okay to do all this at once. Odd properties right there, over 1, not a problem. Multiplying by 1, basically. It's a lot. I don't blame students for separating it. Maybe on other days I would. But do you agree with all my steps here? So we've used the odd property, so that goes to a plus.
Yeah, just give me a second to copy it down if you don't mind.
Sure. And then tangent of alpha is over 1. You can always do that without a separate step.
Yeah.
And I'm building up the fraction because the goal, do this in blue, goal is to get a nice common denominator.
All right. Okay, I see what we're doing here. So we're working with tangent instead of signing, which is what I did.
Right.
Which is much more convenient.
Right. Because if you had done cotangent of alpha plus tangent of alpha, you'd stare at it and go, what the heck am I supposed to do with this?
Yeah.
And you'd probably go, I probably wrap back to 1 over tangent of alpha and think in terms of fractions. But you know what? There's that bug in your brain that's going to go, I don't like fractions. I get that too.
Yeah.
Sorry. I think the best way to do it is to look at it through fractions. All right. So you have to get over those mental blocks, right?
Yeah.
Okay. So now in the next step, and at this point we do need another step. All right. Oh, we're still gonna keep it in purple. All right. So equals. Okay. So let's keep it with the tangent denominator, 1 over tangent of alpha, plus we multiply fractions across. What's tangent of alpha times itself?
Tangent squared alpha.
Correct. Tangent squared of alpha. All right. Down here, 1 times tangent of alpha is tangent of alpha. But you know what? That 1 helps a lot of students out, right? Because otherwise, if this tangent alpha were floating, it's like, what do I do with that? Sometimes putting something over 1, that's the light bulb that people need sometimes. Putting something over 1, something as simple as that, right? Could get that light bulb to go off, right? Any questions thus far?
I'm just trying to remember something really quick.
That's okay.
The desk. Okay, cool.
Okay.
Yeah, I'm good.
So what would be your next step?
1 plus tangent squared alpha all over tangent alpha.
I agree. Add these fractions, 1 plus tangent squared of alpha over tangent of alpha. All right. And what are you kind of smelling up there? We have a 1, we have a square of a trig guy. What might be going on up there?
I forget the term, but
Pythagorean.
Pythagorean, yes.
Yes. Oh yeah, that's true. That's true. Of course, for me, it's like, yeah, Pythagorean, yeah. Okay, great Scrabble. Well, proper.
That's what I was checking, actually. I was like, I can't remember if that's the one that equals cosecant or secant, and it's secant squared.
Secant, right.
Yes.
Remember the co-guys go together. That's the one advantage. In case you're wondering, why are we making 1 over sine of x cosecant of x? The one advantage is that with the Pythagorean identities, the co-guys go together. So cotangent squared alpha plus 1 is cosecant squared alpha, but 1 plus tangent squared alpha is secant squared alpha. When in doubt, assuming that you're not allowed a cheat sheet or anything, when in doubt, seriously, be prepared to quickly rederive things. So you start with your big daddy, sine squared of alpha plus cosine squared of alpha equals 1, right? And you're going, how do we get tangent squared? If you divide by cosine squared over here. So divide all that by cosine squared alpha, also on the right side, cosine squared alpha. And you can derive it. You can derive it. So then you break up the fraction, all right? And then here, the way I'm writing it here is going to be tangent squared alpha. If you're verifying, then I'd ask you to break the fraction up. But sine squared alpha over cosine squared alpha is tangent squared alpha plus, I'm assuming you're scribbling this down, right? Is it cosine squared alpha over cosine squared alpha is 1 equals, hey, what's 1 over cosine squared of alpha? That is
secant squared alpha.
Yeah. So seriously, just being a little mathematician, right? Being able to rederive these. You know what? Derivation can be your friend sometimes. You don't have as much to memorize.
All right. That makes sense.
Right, and you get the other one by dividing by sine squared alpha to get the third one. So don't be afraid to derive things. Sometimes deriving is your friend. You don't have to memorize things, because I can tell you, in my growing old age, I'm forgetting more and more things. So I have to look more at the basic things. What are the basic things I can remember, like this big daddy Pythagorean? And what can I do? How can I derive things, right?
Yeah.
You're being mathematicians. That's the point. In fact, from this class, I'd feel better if you honed your mathematical skills than your memorization skills. We're trying to hone both. Okay, we're trying to hone both. But really, we want to hone your mathematical skills.
I suck at memorizing things, so
Hey, as I mentioned in
being able
class,
to derive like this is necessary.
one of my best calculus students of all time told me, hey, I have a hard time memorizing things, so I memorize the sum identities like you did and derive everything from there. That's a great exercise, and you learn a lot along the way. So no, be a good mathematician. I'd rather have you develop your mathematical skills as opposed to memorizing, although honing both is good. Yes. I wish I knew how to memorize better. No, too many times I'm going to the refrigerator, going to the kitchen going, what am I doing here? That's happening way too often nowadays. I'm going, oh my gosh, I'm only 48. What's going on? All right. Secant squared of alpha over, but when it was having you at like 24, it's like, oh man, I'm losing it. All right, secant squared alpha over tangent of alpha. Now this was a verification. Yeah, I should have been doing this all the time, all along, but I should have been aiming for the target. Hey, we have secant of alpha there. That's sensing to me that I should peel a piece out. So instead of breaking up the secant guy, hey, it's a good thing I checked this. I don't want to break up that secant squared guy. I want to keep a copy, right? Like I'm putting it in the bank. So here's my strategy. Okay, I'm going to move this over to the left here. In fact, I'll move it all the way. Here's a target, all right? Now, I want secant of alpha, I'll put a dot there, times secant of alpha. I want to put that in the bank, all right? So what's the piece that has to evolve into cosecant of alpha, right? Tell me, what fraction has to equal this cosecant of alpha piece here? If you take this guy and you peel out secant of alpha on top, who's left? You can give me the pieces. What pieces are left?
Secant alpha over tangent alpha.
Great. Yeah. And if some students have a hard time with that, those of you watching the video, if you have a hard time with that, I don't blame you. All right. But kind of look at this, right? If it helps, it's that over 1, right? If that helps. But if you peel out secant of alpha from the top, you can do that from the top, not the bottom, right? You can do that from the top, okay? Then we're left with 1 secant of alpha on top and then tangent alpha on the bottom. All right. And then you go, well, how's it related to cosecant of alpha? At this point, you might be going, okay, to heck with it. I'm going to sine and cosine, right? Okay. Any questions up to there?
No, that all makes sense to me.
All right. Well, compound fraction time. Secant of alpha is 1 over, careful. Secant of alpha is the reciprocal of what? Careful. It's not sine of alpha. It's
cosine.
Cosine of alpha, yes.
Sorry.
But again, that's obviously a big source of error because it's like the S's do not go together in the reciprocal identities, right? So it's 1 over cosine of alpha by the quotient identities, right? Because those are the ones that break up into sine and cosine. What's tangent of alpha as a fraction? It's what over what?
Sine over cosine.
Good. Sine of alpha? over cosine of alpha. And again, to everyone, remember that don't drop the argument, because if you're sloppy with the argument, I may well knock you down. Don't forget the times secant of alpha. I often do not give someone full credit if they routinely knock out that argument. Keep that alpha in there. It's important, right? You're taking the sine and the cosine of what? Alpha, x, grandma. What are you taking the thing of? What if it's a substitution, right? Okay, any questions so far? Any questions so far?
No, I see where this is going.
Right. Okay, well, let's go ahead and complete. Yeah, when you're going to a second page, you know it's involved. Okay, all right.
Yeah, no, I'm writing a second line here.
Right. Now, folks, if you think that these cosine alpha guys cancel, they do, but I didn't tell you in class why, so I'll tell you more explicitly why that works. Okay, equals. Right. Okay, I'm going to take 1 over cosine of alpha. I'm going to write that as a big fraction. Assuming this is not 0, and we're not worried about domain stuff right now. When you divide by something that's not 0, you're multiplying by its what? You're multiplying by its...
Sorry, can you repeat that?
Oh, okay. So let's say this is not 0 down here. If you're dividing by something, you're multiplying by its... What's the R word? You're multiplying by its reciprocal. Cosine of alpha over sine of alpha.
Oh, okay. I see what's happening.
Right. Times secant of alpha. Or more directly, if you want to see more directly why the cosine of alphas cancel, well, mentally, you might think, although this might be kind of tedious to write, but mentally you could think, that you're multiplying by cosine of alpha on the top and cosine of alpha on the bottom. Basically, multiplying by 1 here. If you multiply by cosine of alpha over cosine of alpha, right, then you basically knock out these little cosines there. So actually, if you're doing this entirely mentally, that might be the easiest way to do it mentally. But if you're the type of person who would prefer to write things out, since everything's squished here, I guess I could have written these to the left. But another way to do it is if you're taking a fraction, if you're taking something and you're dividing it by something that's not 0, you're multiplying by the reciprocal. Because a lot of students know that rule well, right? Okay. And they can cross cancel, right? Well, these go bye-bye. Right. Because if we were to multiply the fractions, then we're going to end up squishing the tops and bottoms anyway. So we may as well cancel now, right? So what do we have?
One over sine, or...
Now we're getting good, cosecant. I was scared there was something different, but okay. So it's 1 over sine of alpha. Better be. No, I was scared there was something different. Like, what? Okay. Oh, and by the way, folks, do you want to know one of the most common errors here? This is also true with matrices. Miswriting the problem, mistranscribing from step 1. Like, I don't blame people. I mean, when I'm tired, I can easily see myself missing that. And by the way, that's one argument for writing LHS. If you tend to miswrite something that's given you, maybe writing LHS, left-hand side, is better, and just refer directly to my typeset. That might be better than if you try to rewrite it.
Yeah, no, to me earlier, because I thought the target was cotangent times secant.
I thought that too. You know what, Liam?
Yeah.
I was thinking the exact same thing. It's like, no, it's cosecant.
Yeah. I was like, wait, hold on.
I was thinking the exact same thing. Yeah. Okay, so 1 over sine of alpha times secant of alpha. Keep that because that's part of the target, right? That's why we want to keep the target in mind. You don't want to break that up because secant of alpha is part of the target. And now, hey, do these hook up? Yeah. 1 over sine of alpha. Is that cosecant of alpha? Yes, it is. This is cosecant of alpha. Okay. Times secant of alpha. We have that verbatim. If you leave the dot, that's fine. But you basically want this verbatim, right? Mm-hmm. Okay. And then you don't have to do this, but QED, end of proof, right? That's if you want to be fancy. If you want to be a real mathematician. QED. Latin. Quod erat demonstrandum, that which was to have been demonstrated, shown, or proven. All right. Very good. All right. So for people's benefit, here is the solution. I don't know if it's from the book, but here's a good solution in its full glory. Don't forget your equal. By the way, don't forget your equal signs, right? A lot of students leave out the equal signs. You should have the equal signs to remind us of equivalence.
Okay. Do you have time for one more, or
Sure.
do you need to get going? Okay.
I have until 7:45. You got 15 minutes.
Cool. Can we try D then? Because I think that's one that I wasn't sure how to start at all.
Say.
C, managed to get pretty easily, but
D?
I remember, yeah.
All right. All right. So D, and it looks like it's very much a fractions problem, right? Because in chapter 0, I almost did a unit on rational expressions, but I thought we'll pick it up along the way. Because yeah, all right, and we're doing it. We're picking it up along the way. All right. Yes. Substitution.
No.
I say substitution.
Substitute? Okay, cool.
Right. But let's do
Not
it.
what I was going to do. Cool.
All right. So, well, what were you going to do?
Nothing. When I don't know how to start a problem, my first thing is to reach into my grab bag of gimmicks. And the first thing I was thinking was multiply both the tops and bottom by 1, but I was going to have that 1 be,
Well, eventually, we're going to have to do that eventually, but
Yes.
it may not be clear here what you have to do it by. So, no, you're right. We are going to multiply by 1, but at this stage, it may not be clear. Now,
Yes.
okay, so first of all, let me remind myself what problem this is. So this is 5.21D, right? 5.21D, right? Okay. So I know where I am. Okay, 5.21D. All right. Okay, so I'm going to be lazy. I'm not going to copy the left side. I'm in danger of mistranscribing. So I'm going to say, remind myself that I'm starting at the left-hand side. So I have my nice typeset I'll rely on. And here's my target. All right. Now, first of all, let's do a substitution. It's good to declare your substitutions. I'll type these. It's good to declare your substitutions. All right, so we're going to let, there's this one, let u be cosecant of x. That's the only thing I'm really substituting. All right, let u be cosecant of x. Okay, so I'm gonna write the left side now as 1 over u plus 1 plus 1 over u minus 1. And then I'm gonna recopy this. You don't have to, but I'm gonna you can skip that line there if you do this. 1 over u plus 1 times, and we're gonna multiply by 1. But we're gonna multiply by something different. We're gonna multiply by 1 in a different form. We're gonna build up the fractions. The idea is that we want a common denominator. All right. So here's the idea. You don't have to note this separately, specifically, but this is for your benefit. The overall. Go ahead.
So for u plus 1.
Okay.
What is it? I can't remember the term. You used it a while ago when we were talking about I.
Conjugates and complex
Conjugate, yes.
Yeah, you know what's funny? Well, the idea is that we're going to do a sign flip. It's a trig conjugate. Yeah. In fact,
yeah. Okay, so that's what I was thinking.
Right. But in fact, the idea with that is that even if you just had like this guy all alone, or like here, this guy all alone, if there's nothing else to do, you're going, well, I don't know what the heck else to do. Let's try trig conjugates. But here, we have here a more complicated expression where we'll use tricks with fractions, rational expressions, and trig functions. But it turns out to be trig conjugates. That's how we're going to build these things up. So whatever it takes. So the LCD is going to be, anyway, if you do it from the fractions approach, that's the LCD. It's the product of these two guys because they have nothing good in common, right? Right. So how do we build it up? How do we build up each denominator so we get that as the LCD? And it turns out to be the trig conjugate, right? So here, u minus 1. Or, if you like the idea of a trig conjugate, maybe a substitution wouldn't help, and maybe you could do it directly. Okay, but I think for many students, the substitutions will help. Now, u minus 1 over u minus 1, all right? I'll put things in parentheses just for good measure. The fraction bars automatically do this, but this is good visually, I think. Okay, down here, what do we want to multiply u minus 1 by? U
plus 1.
Plus 1, right. Okay. Now, in polynomial theory, we don't call these conjugates, but it's the idea, right, with the trig conjugate thing, right? If we had radicals, right, the idea of a conjugate first came up with radicals, right? Root 2 plus 3, stuff like that. Anyway, now this is to help avoid you having to write all cosecant of x all over the place. Again, if you prefer writing cosecant of x to keep yourself in trig mode, that's fine.
Which I am doing right now, which is why I'm kind of switching back and forth.
Okay, which is better for you?
Personally, I prefer not substituting because
good. Okay.
I don't have a hard time tracking it, but I totally understand why people would.
Okay, so for the video watchers, so if you want to keep it in algebra mode, that's cool. But in a couple of steps, we're going to have to use a trig identity anyway. So it wouldn't be so, whenever you're comfortable, whatever makes you comfortable. Right?
I think
so, yeah.
Feel free to use you because I think it's a lot more your style and I think people understand it better. And since this video is being recorded.
And if you want to see it, okay, yeah. And remember, when you do your work, if you want to use cosecant of x instead of u, it's just a straight substitution, right?
Yeah.
Okay, so algebraically, so see, the idea is that I'm taking you back to chapter 0, where I reviewed this along the way. I didn't have a separate lesson on this, so I could have. Okay, on the top, it's just u minus 1. That's the easy part. Okay. Algebra rule. When you multiply u plus 1 and u minus 1, that was the factorization for what? For u squared minus 1. If you don't believe me, FOIL this thing, and the outer and inner products will cancel. But you should believe me that if you have u plus 1 and u minus 1, multiply them, it's u squared minus 1, because this factored as that times that, right? Plus, well, here I'm just switching the order. You still end up with u squared minus 1, right? On the top, though, we have u plus 1. All right. Any questions thus far? Any questions thus far? The key observation is that these two factors, when multiplied together in either order, you get u squared minus 1. I'm appealing to the basic algebra rule.
Yeah, that all seems like what I've got currently.
Right. Okay.
Okay.
And again, you can be cosecant of x. That's cool. All right. Equals. All right. Common denominator, u squared minus 1. Let's do that first. Okay. Remember, you keep that common denominator. I know there's so much algebra here, students are tempted to add, but no, you still keep that common denominator. All right. On the top, I'm going to do this. I'm going to be super safe. The fraction bar automatically does this, but but here's the thing though. All right. Now, if you didn't have parentheses here, that's fine. You can just rush through. But here's the problem. If you had a minus sign, hypothetically, if you had a minus sign, you would really need to group these. All right. So the grouping here isn't so necessary when there's a plus sign. In fact, some students might benefit from just doing it straight through without the parentheses. But if you have a minus sign there, you better put grouping symbols or distribute immediately. All right. So be careful. We have a plus sign here. We didn't have to be as careful. If we had a minus sign, we'd really have to be careful. All right. And at some point, that's going to bite you. I know. All right. Actually, here we don't need the parentheses. And in fact, I let you combine like terms right up here. All right. Well, I'll do this. I'll write this without the parentheses. Because I'm nervous about crossing out when there are parentheses up there. All right. Well, what happens up on top?
You get rid of both the ones, right?
Right. Those go bye-bye. I can do it right here. Whoops. Okay. Those go bye-bye right off the bat. Okay. But the top becomes what? U plus U. That's not 0. That's going to be what?
U plus U is 2U.
2U, right. Okay. So don't be too embarrassed to state that in your head, right? What's U plus U? It's 2U. Because a lot of people panic. They go, oh gosh, there's U plus U, U times U. All right, so take it, calmly, and just ask yourself, what's U plus U? It's 2U, like back in your Algebra 1 class. All right. Oops. All right. Now, oops. So on the top, we just have 2U over U squared minus 1. And we're done with the algebra phase, the major algebra phase of this problem. Mm-hmm. So the fact that we started off with a sum of fractions here, we've basically resolved that algebraic issue at this point. From this point on, of course, there might be some algebra, but it's more trig. So we're going to sub back. Well, some of you already kept the cosecant guy, that's fine. But at this point, let's sub back. All right, so let's sub back. All right. So 2U was cosecant of x. Okay, so those of you who are using cosecant of x all along, we should be connecting at this point. Mm-hmm. And then on the bottom, cosecant squared of x minus 1. Again, avoid the temptation of canceling. You're not allowed to cancel top bottom if you have two terms, all right? Unless you have like a corresponding factor like that up there, right? Remember, we cancel or divide with factors on the top, factors on the bottom, all right? You're not allowed to strike just these two guys here. All right. So at this point, we're gonna need a trig identity, all right? Well, let's look here. We have here cosecant squared of x. We have a -1, right? So if you have like a square of a trig function, a positive one, a negative one, we might be smelling Mr. Pythagoras, right? And who's the partner that we're hoping for? All right. Well, we're hoping that is cotangent squared cotangent squared of x, and you'd be right. Although, see, the thing is, sometimes there's a negative sign in front, or if there's a plus sign there, it's messed up, and maybe a Pythagorean wouldn't work as well. All right. So it's good to verify that. So just I'm trying to emulate a student. A student might be going, wait, is that right? Okay, so what might a student say? A student might say, well, I know that the big daddy goes like this. Sine squared x plus cosine squared x equals 1. I better memorize that. Okay. Cosecant squared x, cotangent squared x. Oh, wait, cosecant squared x, that's if I multiply the 1 by cosecant squared x. So that might be a tip there. Oh, okay. All right. So let's divide. I put that one way far to the right, but let's divide by. See, we have cosecant squared, cotangent squared. Cosecant squared x is 1 over sine squared x. So methinks we're going to divide by sine squared x on both sides. Okay. If this were a verification problem, I'd break the fraction, but let's see if we can do this visually. Sine squared x over sine squared x is 1, plus cosine squared x over sine squared x is cotangent squared x. All right. Again, if this were a verification problem, please split the fraction first. Equals 1 over sine squared x is cosecant squared x. Okay. So how would I isolate this on one side? Subtract 1. And lo and behold, at this point, I think we can see it's going to work out. So again, I'm not pretending this is a verification. It's kind of like how a student would often approach this. You start with a big daddy Pythagorean identity, all right? Figure out what you should divide by to get these pieces here, right? Cosecant squared x is 1 over sine squared x. See if it works out. 1 plus cotangent squared x is cosecant squared x, all right? Cotangent squared x is cosecant squared x minus 1. Bear in mind, you should write that out in another step if this were a verification problem.
Sorry, just you said you had to go at 7:45. That's 30 seconds from now.
Right.
Should we end this here, or do you want to wrap this up?
We're not done yet. Oh yes, let's wrap this up. Yeah.
Okay. I wasn't sure if you were like completely out of time or not.
I start at 8:10, so that's. But
Okay.
yeah, it depends how much I can push it. I'm pretty prepared though, so I should be okay. All
Thank
right. So you're welcome. So 2 secant of x tangent of x. That's the target. Let's keep the target in mind. So here's one thing. You know what? That's helping me strategize. Okay, I'll keep it in green for now. This is helping me strategize. Okay, how do I get tangent of x? I see. Well, tell me. Do you see a strategy how I can get a tangent of x out of this?
I mean, tangent of x is the reciprocal of cotangent of x.
Exactly. So here's my thinking. 2 cosecant of x over just 1 cotangent of x factor. Oops. And I'm going to leave the other factor separately over here. Put it under a 1, though. You see that? We're still in the denominator. Put it under a 1. Do you agree with that? I can factor this fraction like this because we're trying to be clever. Because what's the idea? You said it.
That's the reciprocal of the target.
Right. 1 over cotangent of
part
x.
Of the target.
Yeah, 1 over cotangent of x is tangent of x. You got that.
Equivalent.
Right. I mean, the whole target thing, that's my term anyway. All right.
I mean, it's good terminology.
Yeah. Equals. Okay, let's take it step by step. Equals. Although it's a different piece, so I don't mind if students work on this now. But 2 cosecant of x over cotangent of x, or you can work on this now. Times, hey, 1 over cotangent of x by the reciprocal identities is tangent of x. So then I dispense with the square there, right? And I get a piece, right? And hey, we have look what we have so far. We have the 2, right? We have the tangent of x. I claim that this cosecant of x over cotangent of x piece is going to end up being secant of x. That's my claim. But you have to show it to me. Okay, don't do it now. You can't just tell me, oh, that's part of the target. No. You got to show me because you're going to need some fundamental identities. Anytime a fundamental identity is appropriate, you got to show it to me. All right. Question so far. So you see we're getting close, right? We have the 2, we have the tangent of x. We have a game plan, right? And we may as well go with breaking the sines and cosines, pennies and nickels. May as well go with that. Questions?
Yeah.
Or alternative? Right?
No, that's actually what I'm doing right now.
Okay, equals. Okay. Although bear in mind, sometimes students come up with the better idea. Students often come up with better ideas. Cosecant of x is 1 over sine of x using our basic reciprocal and Pythagorean. Oh, sorry, quotient. Reciprocal and quotient. All over. What's cotangent of x as by the quotient identities?
Cosine over sine.
Careful. Right. Tangent of x is the other way. Cotangent of x is cosine of x or sine of x. Okay, but make sure not to confuse it with tangent of x, which is what we're used to. That's the problem. When you're so used to one of these, it's kind of hard to adjust to the other. Yeah. And then don't forget the tangent of x. That's in the bank. Although, I would also take this, because you might see this right now. I'm going to do this, actually. And it's okay if you do this right now. A lot of students would say, so do the little sine of x's cancel? They do. But why? And you have to show me why. But why? Because we have the right to do this. Don't worry about domain. We can multiply by sine of x over sine of x. Now, I would actually accept it if students go cross-cross, but I want people to see why that works, because we have the right to multiply by sine of x over sine of x, especially since we're not worried about domain right now, right? We're multiplying by 1. And then then later on, we have, don't forget your times tangent of x. But so you better decide now, do you want to write tangent of x, or do you want to start multiplying by 1, right? What happens? Boom, boom. This works. Because we have a, see, if that were a plus sign, it wouldn't, but times, this works. I like leaving ones there as it's good to indicate what's left. Ones, right? Over down here, basically ones. All right. We can do that, and we should be pretty close. I think I can go ahead and finish it up here. Yeah. Equals, well, we basically get 2. Let's break out the 2, right? 2 is part of the target. Let's break them out. 2 times 1 over cosine of x, right? That's what's left of that ugly compound fraction. Mm-hmm. Okay, with the 2 out there, right? 1 over cosine of x times, times tangent of x. And does 1 over cosine of x equal secant of x?
Yes.
Nod? Yes. But write it to secant of x, tangent of x. And if you switch the order, switch it in the right way, get the target verbatim, to secant of x, tangent of x. That's good. If you wish, you can write QED, but that's okay. We've hit the target.
All right, cool. I feel a lot more comfortable with the with attempting the last 2 now. I feel like I understand what I've been missing and the strategies I need to be utilizing.
Oh yeah, and this was a tricky one, very involved one. Okay, and you know what? I'm going to remind myself, and thank you for allowing me to record this. I'll remind the class that I have these ones. In fact, I'm going to tell the class that I have these ones from office hours.
Okay, I'll be letting the people on Discord know that, you know, if they need help solving it, I can help them now, or if they want to go watch the video, it'll be up at some point, hopefully.
Yeah. In fact, I can upload it. Maybe not right now, but maybe after, maybe tonight. So by 10:30 p.m., I'd be thinking after my stats class, I think I can upload this. Yeah, I think I can upload it by, how long does it take to process? It depends how long it takes to process. By midnight. I'd say by midnight, they'll have access.
All right, cool. Thank you.
Okay,
That's
thank you.
really helpful.
Oh, yes. No, it helps me too. It helps me, it keeps reminding me how to teach this stuff, right? It's like,
Yeah.
yeah. Okay, very good. Thank you so much. All right, do you have any other questions or any?
No, that's pretty much everything. Thank you so much again for all the help. And
Thank you. It's good to have visitors. Okay, I'll see you soon.
take care. Bye.
Take care.